Hi and welcome to Module 7. Today we're talking about our outcome about our structural formula, properties and functional groups, including our primary, secondary and tertiary alcohols. So in our previous lesson we were looking at how we name, using the IUPAC naming system, our different alcohols that we have. And while we were naming them using the regular conventions that we had discussed previously, it was mentioned that there were certain alcohols called primary, secondary and tertiary. So today we are going to look into what does that actually mean, as well as how they look in their structural formula and how that functional group affects the properties of alcohols. So firstly, let's talk about the three different types of alcohols that we have. So the way we name them is according to the number of carbon atoms is attached to the carbon that the hydroxyl group is attached to. Now that sounds quite convoluted, and we'll have a look at the written definition first, but it'll certainly make a lot more sense when we have a look at the pictures. So our primary alcohol is one where the OH group is attached to a carbon. Now that carbon is only bonded to one other carbon. So it's a terminal alcohol where it is attached really to the end carbon. The next type we have is our secondary alcohol. So what's happening here is it's not on the ends of our alcohol structure, but it'll be on one of the ones in the middle of the structure, where that carbon that it's bonded to will have a carbon on either side. And then we've got our tertiary alcohols, and that's where the carbon that the hydroxyl group is attached to is actually bonded to three other hydroxyl groups. Like I've said, that'll make a lot more sense when we have a look at these pictures on the next slide. So if we have a look here in our primary alcohol group, and I know you don't always like this condensed form, and I do have pictures of the more branched version, but you can see here this hydroxyl group is attached to the end. So it's attached to the end carbon. That end carbon is only attached to one other carbon, no other carbons there. With our secondary alcohol, you can see here's our hydroxyl group on the second carbon here, and it's attached to this carbon. Now if you have a look at this, there is a carbon on the other side and the other side. So it's attached to two different carbons there as well. Now looking at our third type, which is our tertiary alcohol, we can see here's our hydroxyl group. It's attached to this carbon here, and this carbon here is attached to 1, 2, 3 other carbon groups, which gives it the name a tertiary alcohol. So let's look at that in a different form now. So if we look at this one, this is our primary alcohol, and this picture is actually in your booklet. So we're having a look here. The hydroxyl group is attached to an end carbon. So you can see over this way we have our hydroxyl, our hydrogen, our oxygen, and it's attached to a carbon group. This carbon group here is only attached directly to one other carbon. So it's a primary alcohol. Looking at the next one, in this secondary alcohol, the hydroxyl group now is attached to a non-terminal. So it means one of those middle ones. So here is my hydroxyl group. It's attached to this carbon here, and this carbon here is actually attached to 1 and 2 other carbon groups. And so we will call that a secondary alcohol. And if we look at this one here, these are our more complex structures. We can again see here's our hydroxyl group. It's attached to this carbon here, and this carbon here is attached to 1, 2, 3 other carbon groups, giving it the name a tertiary alcohol. So that will help A with our naming and B with identifying the different types of alcohols they are. it is often, and in a lot of the questions that we have been doing in class, many of the answers given will have their answer. For example, methyl propane 2-ol, and then underneath we'll write tertiary alcohol. Doesn't hurt. So let's have a look here. How does an alcohol affect the properties? Well, that hydroxyl group actually does provide their characteristic properties. It really affects the chemistry that they have. So we'll talk about why that is in a minute. But also, many alcohols make good solvents. If we look at all of our other alcohols that we've had a look at, we have the OH bond, and that's forming our polar bonds. And then so due to that electronegativity difference between them, and also the carbon and the oxygen also are very polar bonds. So we have the polar region down the end where the hydroxyl group is, and then we have the other part of the compound, which is, or the molecule, which is a non-polar region. And that actually gives it its solubility. It actually allows them to be partially soluble in a range of other solvents, but it also makes them good solvents as well. So, having a look here, the properties of alcohols, so namely boiling points and solubility, are really dependent on two factors. And the first is that presence of the hydroxyl group. And we'll talk about that in a minute. And also the size of the hydrocarbon chain, like with our alkanes. The larger the size of the alkane chain, we were increasing more carbons, more hydrogens, and therefore increasing the dispersion forces there. So looking at the first one there, the presence of the hydroxyl group, what happens, and we'll see on our next slide, is we're able to form hydrogen bonds with other molecules and also with water. And what that does is produces our hydrogen bonding, and they're quite a lot stronger than our dispersion forces. So let's have a look on our next picture here, for example. I'll go back to that other slide in a minute, but this picture here, you can actually see that we've got ethanol here. We've got a molecule of ethanol here, another molecule here, and another molecule here. So at this end, we have our dipole forces there, the oxygen and the hydrogen, that electronegativity difference, and we've got this hydrogen on the end. It's then able to bond with the oxygen of the next hydroxyl group. This hydrogen here is bonding with the oxygen, again due to the difference in electronegativity of this oxygen of the hydroxyl group. So there we've got our hydrogen bonding, and that hydrogen bonding really increases those forces. They're so much stronger than the other forces that are acting there. So when we compare an alcohol with an alkane, even though they might be the same length chain, so our dispersion forces are the same, we've got other things happening there. The hydroxyl group is making hydrogen bonds which are stronger, so we've got greater energy required to break those bonds, hence the boiling points are going to be significantly higher. So going back to this slide here, you can see there the boiling point of an alcohol compared to alkanes relates to the energy required to overcome. And as we've already discussed before, the increase in the size of the hydrocarbon chain also increases then the dispersion forces, which will also affect the energy required to break them. So what we're going to do in class is we are going to do some data analysis of the boiling points of different alcohols and compare them with a similar size alkane and see what comparisons we can make there. All right then, see you in class tomorrow.